So today I'd like to welcome Dr. Andrew Waterhouse, who earned his bachelor's degree in chemistry from University of Notre Dame and a Ph.D. in organic chemistry from UC Berkeley. He joined the UC Davis Department of Viticulture and Enology in 1991 to research various aspects of wine chemistry, and his graduate students and postdocs are now winemakers, researchers, and faculty across California and around the world. So as you probably know, climate is a key factor in grape characteristics and wine quality. And today, Dr. Waterhouse will discuss how changing climate may affect famous wine growing areas and what mitigation strategies are possible to address those impacts on grape growing and wine production. So Andy, Dr. Waterhouse.
Going to talk about how climate affects grapes, how that affects wine, and then specifically the effect of temperature, which is very important, and ways that we might be able to deal with changing climate. On the next slide, and questions are welcome at the end, apparently. Okay, so the flavors in wine really come from several sources. The first is the grape, although wine is not grape juice. The flavors are very transformed. But when we look at, what is this wine going to, first thing that's important is the flavor of the grape, and then where it grows has an effect on the flavor. And the site, of course, has a lot to do with that, the effect of the climate, right? And so on the next slide, this is a map of viticultural regions in California that was defined by Professor Amarine and Winkler many years ago. And on the next slide is a better copy of that. So what they did was they defined different regions of California that were suitable for growing grapes. And they defined this based on what's called growing degree days. So it's sometimes called a Winkler index. But they have different regions 1 through 5. And these different regions are defined by the accumulated heat during the summer. So the regions that are closer to the ocean, and those are in the blue and the red colors, those are the coolest regions in California. And then as we move inland, we get to the warmer regions. So the warmest regions are in the Central Valley, and they're that sort of a dark orange. And depending on the region, grapes are better or less suited for that place to grow. And part of finding the right place to grow your particular grape is to define what region it grows best in. So on the next slide, we have okay. So this is how how this is calculated. You take the average temperature of the day above 50 degrees Fahrenheit or 10 degrees C, and you start adding that up. So, if every day your average temperature is 60 degrees, after 5 days, you've got 50 degrees added to your growing degree days. And throughout the summer, this adds up. And so by the end of the season, you have numbers that are between, 2,000 and 4,000, basically. So depending on where the grapes grow or where you are in California, you may want to plant one variety or another depending on its suitability for that particular place. Now, this is approximate, but when this came out, Winkler and Amarine really pushed the growers to grow, I would say, higher quality grapes in better locations. Because when this came out, almost all the grapes were grown in the Central Valley, and it's quite hot. And they demonstrated through about a fair amount of experimentation that the quality of those wines were not that good because the regions were too hot for the grapes that were being grown. So they encouraged people to grow the grapes in cooler areas and specific varieties. So on the next slide, this is a list of of varieties and sort of what regions they would be best suited for. And at the very top, it's the coolest area. And there, the grapes that are best suited for those cooler sites are Pinot Noir, Chardonnay, Gewürztraminer, and so on. And then as it gets warmer, you get different grapes are suited. And then with the very hot areas like that region 5 at the bottom, from their assessment was don't grow wine grapes where it's that hot. Okay, grow table grapes like Thompson seedless. When it's quite hot, you can get a really big crop and you can grow lots of grapes, but the quality in terms of wine isn't there. So you can see that there's different areas which are better suited. So really the wine grapes that we're familiar with are the top 3, the coolest areas. And for instance, Chardonnay and Pinot Noir, if you're familiar with Napa, are grown largely in the Carneros area, which is closest to the bay, which is the coolest area. And then as you go north into Napa, it gets warmer and warmer. Up in Calistoga, it's probably, well, a warm region 3. Okay, so let's go on to the next slide. So if you want really high quality fruit, what you want to do is, and this is the current convention, is you grow grapes in the coolest area where they really can ripen. Okay, so you're sort of at the limit of what you can grow. Okay, so you'll find if you find a really good, so that's a picture up there of a high quality vineyard, and you see that when you grow it in a location where the amount of heat and warmth is limiting, then the vine does not get very big. And this has a lot of ramifications. Perhaps the most important is that the grapevine isn't too big, okay? And as a consequence, the grapes are exposed to and you can see them, and they're exposed to the sun. And getting some sunlight on grapes is very important to quality. So if you grow grapes in a nutrition limited area, then the grapevine naturally has, it's small and it doesn't have a lot of leaves. Now, on the other hand, if you're in a warm region with very nutritious soils that have like a lot of nutrition in them, then the grapevines grow very big. And there's a picture at the bottom of grapevines down by Madeira. And there, the soil is not limiting, the water's not limiting, and the grapevines grow as these huge bushes. Now, when that happens, you can get a very big crop, which is good because you're not going to get a good price for those grapes, right? But the grapes, as you can see, the grapes never see the light of day. So the quality isn't, so when you look at a high production area where they're making grapes that are sold at a low price, one of the reasons is that the grapes are, coming from vines that are producing huge crops, but the vines really never see the light of day. Okay, so let's go on to the next slide. Now, because grapes are so responsive to climate, there are specific places where quality is the best. And you know that already because you're familiar with viticultural areas, right? You've heard of Bordeaux, you've heard of Burgundy, you've heard of Napa, et cetera. The reason that you've heard of these places is that they have the right climate for the grapes that are grown there, okay? So this has a list of a couple of the different regions and what those areas are famous for. And it's the climate there, the temperatures, the daily temperatures affect flavor development. And on the next slide, I'm going to get started with a little description of this. So those flavor components are we call them secondary natural products. So these are things that the grapes grow in response to their environment. Okay, so primary metabolites include sugar, protein, fats. Every grape has that, but the amount of the flavor components depends on the environment. And so that's why we have wines that taste better or worse depending on the location, because it's these chemicals that the grapes are making, these secondary metabolites, are produced differentially depending on the climate. So terpenes are one of the volatiles. I'll be discussing that. And the phenolics are the things that are the tannin and the color. And I'll have another discussion on that. So go ahead to the next slide. So Riesling is the most important high quality grape in Germany. And it's the rating system in Germany, which I'll show you, shows that as the location or the season, actually, even each year, they rate the temperature of the season. As it gets warmer, the quality level goes up. And so you'll see if you buy German Rieslings that some years they have a lot of high quality wine and sometimes they don't. And the reason that they don't have a lot of high quality wine is that it didn't get warm that year. And that on warm years, they have more of the high quality wine. Now, you would think, okay, well, if you need warmth, then we can grow great Riesling here in California. But it turns out we can't grow hardly any decent Riesling in California. And the question is, well, okay, if warmth is important, then why can't we just grow all this great Riesling in California? So on the next slide, in Germany, the quality system is based on the amount of sugar accumulated in the grapes. And they have the Germans are very good at organizing everything. So there's this quality ranking system and there's different levels. I think the next slide so it actually has the specific categories. So if you buy these wines, they're labeled. So Cabernet is the lowest level of sugar and the lowest quality according to their system. And then Spätlese is a little bit better and Auslese is even better. And then the top two or the bottom two, the Baron Auslesen and the TBA are really dessert wines. But if you're buying a German Riesling, you might want to get a Spätlese rather than a Cabernet if you want the better wine. So this is just defining the amount of sugar those grapes accumulate during the summer. So in California, we could get, whatever, we can get 25 bricks without breaking a sweat. So you think, well, we must be able to make great Cabernet. Okay, but story continues. Next slide, please. Okay. So the aroma of Riesling is based on particular chemicals I'll show you on the next slide. And these are called terpenes, and they're specific chemicals that have this sort of floral, fruity aroma that, well, if you're familiar with Riesling, you think it's wonderful. It's funny, in the US, Riesling goes through these phases of popularity. Unfortunately, Americans don't really seem to get the flavor of Riesling, even though on a global basis, it's considered one of the best grapes in the world. But Americans just can't get their head wrapped around it. But anyway, okay, so the flavor of Riesling is based on these things and a few other things I won't discuss, but continue. So these people did an experiment in Germany to try to figure out like why, what's the relationship here between sugar accumulation and flavor. And I think this is the crux of the matter. Like if we have more warmth, we can get lots of sugar accumulation. And then what's the disconnect with flavor? So they analyzed sugar accumulation and terpene accumulation. Okay. So on the next slide then, what they did, and this is a tricky experiment. So they grew Riesling and they harvested it 4 times. Okay. So 4 times during the season. So these are not very far apart, and they were like when the grapes were actually getting ripe enough to harvest. Now in Germany, their idea of ripe enough to harvest is very different from ours. But anyway, and then so they harvested at different times, and then each time they harvested, what they did was they separated the berries based on sugar levels. Okay, so they harvested and they separated into 4 categories based on sugar levels. So they can separate, and it's this technique you can use, floating. You basically float the berries in sugar solution, and depending on if they're denser or lighter than the solution, they'll float or sink, and you can use that so you can separate your berries into these 4 categories. Okay, and it's allowed them to distinguish between sugar accumulation and flavor accumulation. Okay. So the next slide, this is the data, okay? So I'm gonna get my pointer. All right, so they have these 4 harvests, and at each harvest, they separate it into these different sugar levels. So this is Brix is a sugar level. And if you're familiar with this at all, you would know that in California, we don't harvest anything until you get to 22. So these are very unripe berries by our standards. Okay. All right. So here, this is harvest 1. So this was the earliest harvest they did. And you see they had berries with these 4 different levels of sugar ripeness. Now, what's on this axis is basically the amount of terpenes. And so what you can see is that at this first harvest, the amount of terpenes you got increased with ripeness, okay? It didn't increase very much, but it does increase, right? So and there's this funny point here, but if we look at starting from 10 to 12 and up to 16 to 18, you get more flavor, right? Essentially as you harvest riper fruit. Now, then this line here shows the accumulation of flavor at the 4th harvest. And again, they segregate the berries. And what you can see, 2 things here. First of all, by waiting longer, you get more flavor. Okay, so at any Brix levels, you get more flavor. So if it doesn't matter about the sugar level, as long as if you wait longer, you're going to get more flavor. Okay, but you get much more flavor at higher sugar levels, and it's very, very high, much, much higher. Okay, so there's 2 things happening in terms of sugar flavor accumulation. One is higher sugar, but also waiting longer. So the problem we have in California is that we would reach this high level of sugar at this first harvest, right? So the problem in California is the reason we can't grow good Riesling is that it's too warm and we get the sugar accumulates in the grapes before the flavor shows up. Okay. Whereas in Germany, where they're coaxing the grapes to ripen, by the end of the season there, they've actually accumulated some flavor. So the problem you can see here is that there's a disconnect between flavor accumulation in grapes and sugar accumulation. And it turns out these terpenes aren't the only thing where this happens. And this is why really planting these, the famous grapes, we plant them in the coolest location where we can get them to ripen, because it takes the longest amount of time for the sugar to accumulate, and that gives the grapes the longest time to accumulate flavor. And so we see this again and again, not just with terpenes, is that you get the best quality fruit for wine in sites where you can just barely get it ripe by the end of the season. If they ripen really fast, you don't have flavor accumulation. So you can see a place like Napa, where we're right now making top quality wine. If it gets warmer, we won't have any trouble getting the grapes ripe, but we may have a lot of problems getting or having the grapes accumulate those wonderful flavors. So that's the risk. It's not that we can't grow grapes, but we can't grow great grapes when it gets too warm. Right. Move on. Let's move on. So, well, this just restates what I already stated. So, I'm going to skip to the next one. Okay. So then I'm going to talk about some specific experiments that have been getting done with James Campbell and Beth Forrestal. I've been involved in these to some extent. But James was one of my PhD students, and he did part of this project while he was a student working in my lab. So on the next slide, we're going to be talking about pigments this time, not aroma. So pigments are the red colored substances that are in grapes, and look at the effect of temperature on the accumulation of those things, and then what we might do if the climate gets warmer. So on the next slide, we've got a picture here. There'll be a test at the end, by the way. So, so this is a molecule called anthocyanin, generically an anthocyanin. And there's a bunch of different ones. But this is the pigment that's found in grapes. And there's several variations on the structure, mostly variations over here, and then there's different things attached. Now, this doesn't occur only in grapes. You might guess from the picture over here that these are also found in flowers. So we find anthocyanins as the red pigment and sometimes the blue pigment in flowers, grapes, but also many other fruits. So for instance, the berries, raspberries, blackberries, all have the color based on this class of compounds. Let's see, eggplant skin. The two places where you don't find anthocyanins, and that, well, three, there's tomatoes, have lycopenes, watermelon doesn't have any anthocyanins, and beets don't have anthocyanins, but most of the red fruits and vegetables that we consume have these same substances. So on the next slide, depending on the specific structure, it can actually affect the color. So depending on the specific types of structure, you can get colors that go from orange to purple. So on the next slide, there's a picture of a flower. So now the flowers actually use a few more tricks besides just the chemical itself, but they have different metals present like aluminum or zinc, and you can change the color as well. So flowers have figured out that they need to have a large diversity of colors, so they use that. In the next slide. Now it's in grapes though. What's the story about grapes? So on the next slide, grapes accumulate this pigment during a very specific phase of ripening. And this is a little diagram showing ripening from the beginning of the season up till harvest. And if you're familiar with visiting a vineyard that has red grapes in it during the growing season, there's a time that you might have heard referred to called veraison. And veraison is a specific time, it's about midway through the ripening cycle. And if you're growing red or black grapes, the grapes don't show any color until that period. Okay, so in the early phase of the season, which is over here, you would be accumulating things like acid and tannin. And the grapes are really not very tasty. Believe me, you don't want to eat them. They're extremely astringent and sour. But after veraison, they start accumulating sugar. Okay, and the other thing that happens if they're red grapes, then they also start turning color. Okay, so they'll start accumulating the pigment, which are the anthocyanins. Okay, so prior to that point, red grapes have no color or no red pigment, and after that, they accumulate it. Okay, you can see here as the season continues, this shows the berries are getting bigger, they're accumulating sugar, and they're turning red. And this has got some other info there. All right, now let's go to the next slide. Okay, now what is the effect of temperature on the accumulation of this color? And this is we didn't do this. This is somebody else did this experiment. So, but this is a very diagnostic experiment. And this is, this is just the number of days after the flowering started. So this is data accumulated during the growing season. Okay, and what they did was they did this, they actually had machines out there to heat up the grapes. Okay, so they're controlling the temperature of the berries through the growing season. And what you have here is, this is degrees centigrade. And so 20 is basically 68 degrees Fahrenheit, so a cool day, up till 35, which is quite warm, not too hot. We hit 40 degrees around here pretty routinely. And you can see the amount of anthocyanin is basically almost directly related to temperature. In other words, at the cooler temperatures, accumulate a lot of anthocyanin, and at the hotter temperatures, much less is accumulated. You'd say almost half, right? So under higher temperatures, you'll accumulate less of this pigment. Now you might say, well, how much do you really need? And it turns out in quality of red wines is almost directly related to the quantity of these anthocyanins. In fact, in Australia, many of the growers are paid for their grapes based on the amount of pigment that are delivered to the winery. Okay, so now by themselves, these pigments really have no taste. But it turns out during aging, these things react with the tannin and actually soften the tannin. So if you have low levels of pigment, there are certain varieties that have a lot of tannin and low pigment. The wines are rather harsh and take like decades and decades before they become palatable. But if you have a large amount of anthocyanins, then these chemical reactions can occur in a couple of years, and the tannins taste much more palatable very quickly. And so the amount of pigment that's available on the grapes is in fact a key factor in the quality of red wines. And it's not just because it makes it red, it's because it alters the taste of the wine. So if you know that if it gets warmer, I'm going to have less pigment, it's very worrying. Okay. So you can see there are two experiments here which showed similar results where the daytime high temperatures really had a big impact on the amount of pigment that accumulates in the grapes, the amount of those anthocyanins during the growing season. So on the next slide, this data was used to project. This is in a modeling experiment that was described for Western Australia. Actually, they make very good Cabernet out there, Margaret River, if you ever had any wines from out there. And so some scientists projected that essentially the amount of pigment available in their Cabernet is going to go down as the temperatures rise. So they're very concerned about that. Okay, you can go on. Okay, and then this shows a map of Napa. And this shows the region, the Winkler regions, as defined by what are called the growing degree days. And what you can see is that within Napa, there are specific places that are particularly cool and other places that are much warmer. Okay, so the mountain areas along this edge here, and this is, so the center of Napa right here is it's a valley. And along here and along here are the hills on the two sides of the valley. So these are cooler areas than the center of the valley. All right, so go to the next slide. So James did a couple of experiments on two different periods in 2015 and 2021, looking at the accumulation of anthocyanin and other polyphenolics. And he actually found that there was a strong correlation between the amount of pigment and the region that the grapes came from. Now, because the growers in these different areas are going to be very sensitive to this data, he hasn't organized it yet, so it's publishable. Not sure how to convey this information to the growers in Napa, but as we start getting more and more warmth coming into Napa, there are going to be issues depending on where you are, whether you can maintain quality in Cabernet. But let me move on to, so this is the sites he did. So he sampled, I mean, in 2015, he had thousands of samples. So he was getting grape samples from 75 sites in Napa Valley throughout the growing season. So he had literally thousands of samples. So the data set is quite convincing. On the next slide. This shows the amount accumulation of those anthocyanins during ripening. So this is the ripening, as the grapes get riper. So this is the Brix curve. So you've got here See, this is 15, 20, and 25. And you can see we're getting grapes way out here at 28. When you see there's a lot of scatter here. And the reason for the scatter is that we've got different sites that have different temperatures. So on the next slide, he's then broken these down into different regions. These are a little hard to see, but these two lines at the top that have the highest amount of anthocyanin are these two mountain areas. So the eastern and the western mountains in Napa. So even today, the grapes that are growing on the mountains, like the Vaca Mountains or the Mayacamas Mountains, have higher levels of pigment than the grapes that grow in the center of the valley. Now, it's been known for a long time that mountain fruit, as it's called, does have more tannin, but this shows it also has a lot more pigment. So I go on to the next slide, and this is a later data set which showed very similar things. It also showed a big drop off here, and this is from a heat wave that occurred in that region. So we definitely can see that even within Napa itself, the local temperature, the accumulated temperature during the season has an effect on pigment. So let's go on to the next slide. So there are various things that growers could do to cope with the change, with climate change that we're expecting. And a number of things have been tried to mitigate heat. So I'll mention what these are. So kaolin is basically, it's a mineral that you can, it's very inexpensive. You can spray it on the vines, and it's white. So you can get this, you can spray it on the fruit, either spray it on the fruit or spray it on the whole vine. Usually you spray it on the fruit, and that reflects light. So it helps keep the fruit cooler. So people are using this. I don't have any data on this, but this is the kind of thing people are thinking about, like how I'm going to keep heat off the grapes. Remember, if you have a high quality vineyard, that the grapes see sun exposure, right? So one of the tricks, like to keep the grapes cool, is to have more leaves. But then if you have more leaves, you don't have the sun exposure. So it's a big trade-off. Do I risk burning the fruit by having a lot of sun exposure, or if I don't have enough sun exposure, I don't get high quality fruit? So anyway, kaolin is one of the options. So misters. So this would be like what some of you probably have in your back patio. You have a spray, a device that mists water out and cools things off. So this is being tried as well. And the advantage in Napa Valley is they have a lot of resources, so they can try all kinds of things. So they're trying this. And now the downside of the mister, of course, is you have more humidity, which means mold. Okay, so mold is one of the problems that grapes have in terms of quality. So you can cool things off with water, but then you take the risk of getting more botrytis or other molds on the grapes. So it's not completely, it's not straightforward. Do I just mist or not? Another thing is shade cloth. So we have data on shade cloth. So you can put the shade cloth up to shade the grapes later in the season and just shade the grapes. So you keep the sun off the grapes so the leaves still function. Or irrigation. And I mentioned less fruit exposure. So you can just have a bigger vine. You don't remove the leaves, and you'll have more shade. Okay, so let's go to the next slide. So this is a picture from the vineyard where shade cloth was being used. So this was actually in the mountains of Napa up in the Mayacamas. And there were two treatments, one with 40% shade cloth and one with 80% shade cloth. And you can see how they was added to the vines at veraison, right? So the grapes were allowed to grow until they started to soften and turn color without any shade cloth, and then we put the shade cloth on. So the shading only occurred after veraison. Then we take the grapes back to the lab and do an extraction so we can measure the amount of pigment. Okay, so the next slide. So this was the result of the experiment. You could see that This is through the season. And what you see is the sun-exposed fruit, right, accumulates the most amount of anthocyanin, and the shade cloth actually reduces anthocyanin accumulation, right? So the shade cloth under this scenario is actually reducing the amount of pigment, right? So you're keeping the grapes cooler, but without the sun hitting the grapes, they're accumulating less pigment. Now the treatment, the 40% treatment actually at the end caught up, but the 80% treatment didn't. So we can use the shade cloth to keep the grapes from getting too hot, but by excluding the sun, we're also reducing the amount of pigment formation. So it's not a simple trade-off. All right, let's go on to the next slide. So another experiment that was done was to help growers to deal with a heat wave. So, this was done, I think, in the Lodi area, where these days, or at least maybe 10 years ago, there might have been a couple of heat waves during the summer. Now, by the heat wave is defined in this case by 3 days over 40 degrees C, which is 104. So if we have 3 days, essentially over 100 degrees, it's considered a heat wave. And the question was, could we do anything to help the vines cope with that? And the experiment was to apply extra water. So under these conditions, what you do is you have your normal irrigation regime, but then when you see an impending heat wave, you apply a whole bunch of extra water. So the amount of water, so there's a term called the ET, which defines the amount of water that the grapevines use normally. And so with this experiment, you apply twice as much water as that would suggest and 3 times as much. And you see what happens, okay? So we evaluate the amount of anthocyanin in the berries through the heat wave. All right, so go to the next slide. So what we see here is in fact very promising, which is, so this is one experiment done in 2019, and the red line here is the control. So those vines got no extra water, and you can see that the amount of anthocyanin is going up, but then right after the heat wave, it goes down. So clearly the heat wave is clobbering the vines and decreasing the amount of pigment available, and it stays low throughout the rest of the season. But when we added water, depending on the amount, it actually preserved the pigment. And at the end of the season, the 2 treatments were essentially equivalent. And that's very important to know, because it turns out you don't have to add 3 times as much water, but during the heat wave, you need to add, if you add double the typical amount of water, then you can actually preserve the pigment at the end of the season. So it was a very interesting result. And how is it working? It's a little hard to say. We think perhaps the extra water allowed the vines to cool themselves off, right? Because the plants are surviving by evapotranspiration. And by having extra water, they could evaporate more water, which would cool them off. And there was another experiment next year. Oops. Oh, go back. Had a somewhat similar result where the control vines here lost color after the first heat wave. There were 2 heat waves in this particular season. They were able to recover, it looked like, but after the second heat wave, again, we had a discrimination between the control vines, which lost a lot of color, and the treated vines, which didn't lose as much, okay? So it seems that perhaps applying water in anticipation of a heat wave is going to be a way to deal with this. And while these days we anticipate, maybe 1 or 2 heat waves per summer, the climate scientists are saying we can expect 4 or 5 in the future. So really being able to cope with these high temperature events and maintain quality is going to be very, very important. All right, let's go to the next slide. So in terms of using these, there's some questions here. I guess one issue is, will we have the water to do this? If applying extra water is helpful, how much extra water do we have? This year, probably plenty, but if you think back just a couple of years ago, we had a tremendous water shortage. There were actually vineyards in Sonoma where basically they had to give up growing the grapes because they didn't have access to any water. So it could be a very serious limitation. And in terms of shading, it may be helpful. There's some other things that happen to the berries that maybe not be so positive. But anyway, there's also the labor and the complexity of doing that. So there may be some labor costs involved. So when farmers are faced with, having to cope with climate change, they're looking at all these different options. And it's not just the chemical result that comes out, but, like how much did it cost to do that? They have to juggle all this stuff in their head, trying to figure out how to cope with. But at least at this point, we're starting to develop some tools to give farmers ways to cope with this. And they have to figure out whether they can afford it, whether, and then the people who buy the grapes have to figure out, okay, can I still make great wine if it has like a little bit less pigment, right? So lots of questions they're going to be facing in the future. All right, the next slide. All right, so this just goes over our conclusions, which I think I've covered already. The shade seems to work, the irrigation seems to work. All right, let's go to the last slide. All right, so now we can stop and you can ask some questions.
So is one of the solutions just moving the grapes up the hills?
Yes, that's called adaptation, not mitigation. We could move, there's a number of wine companies that are buying land in Oregon and Washington. So yes, you can move the grapes up the hill, but there isn't any land left, right? So if you've paid, current prices in Napa are about $500,000 an acre. You bought 10 acres. That's a pretty big investment. And really the question is, how long can we hang on to that? Another adaptation is to plant different grapes. You've got grapes that are better adapted for a warmer site. Right now, if you grow Cabernet in Napa Valley, you can get between price is infinite actually, $5,000 and $10,000 a ton. But if you say grow Syrah, you'll get like 1/10 that much. And the grapes that we're thinking about maybe planting there, Tempranillo is better adapted, comes from a very warm site in Spain. I don't think you're going to maybe get $500 a ton for Tempranillo. So if you paid $500,000 an acre, you're not going to be able to pay the rent if you plant Tempranillo. So there's all these questions that, interlocking issues that make it tricky. So you can be sure that people are going to want to keep Cabernet in the ground in Napa as long as they possibly can.
We have one question two questions now from chat. First is, how much did recent years' wildfires damage the different regions where wine vines and wine production? First question.
Okay, yeah. So smoke taint and wildfires is a huge issue. In fact, there's several people at Davis working on this, and people all over the West Coast are working on this. So the wildfires don't damage the vines on a permanent basis. Okay, so in general in Napa, the fires that we did have 2 years ago and then prior, damaged just a few vines, really, because vineyards really don't burn. Some buildings burned down, but the problem was that vintage, the smoke from the fires contaminated the grapes. The grapes actually act like sponges and suck up the smoke, and the wine then will taste smoky. And there were all kinds of lawsuits over this because some people refused to pay for the grapes that they had contracted for because they didn't want to make smoky wine. And then the growers were saying, well, you don't know if it's smoky till you make the wine, you know, around and around. So there were all kinds of, so there's a lot of issues, and we're trying to help them come up with ways to analyze the grapes to be able to predict, have these grapes been contaminated or not? That's one really big question, which will hopefully alleviate some lawsuits in the future. But the contamination, you know, isn't persistent. So the grapes get contaminated, but the next year the grapes will be fine, right? And then the vines generally don't get damaged. I mean, the buildings burned down, and in the 2020 fires, a bunch of buildings burned down, but not many vines. So is that a long-term effect or a short-term effect? The other thing is, and this is kind of sad to think about, but once you have what's called a fire scar, it doesn't burn for quite a while. So if you burn down all of Napa Valley, then it's fine for the next 10 years because you won't have any more fires because all the trees that would burn have burned down. Okay. And that was a factor because we were looking at, is the fire going to go here or there? Because there was this fire started in 2020 and the fire folks were saying, well, we don't have to worry about over here because that burned down 3 years ago. Like, okay, so once we burn everything down, then we're set for a while. I mean, and that is the situation in Napa, is that a large part of it now has, and what's burning are the mountains, right? That are on the sides, which are not planted. They've got trees, I mean, not planted to grapes. They've got trees of various sorts, pine trees and some oak trees. And that's what's burning. And that's what's causing the contamination of the fruit. And in 2020, it was bad. Like half of Napa Valley was not made into wine. So if you think about Napa Valley, okay, so Napa Valley is 40,000 acres, which is like 10% of the state. In terms of acreage, it's 50% of the value. So we took half, we essentially lost 1/4 of the wine value in 2020, which is a huge hit for the industry. Okay.
Another question from Zoom. Would the botrytis from irrigation make good quality late harvest red wine?
Wow, I don't know. Maybe. I don't know of anybody making a late harvest, but botrytis infected wine with red grapes. I doubt it.
I think I have 3 questions. First, way back in the beginning. At a time. Okay. At one period of time, they talked about a lot of the restaurateurs here in the Sacramento and surrounding areas were shipping their scraps, their garbage, but non-meat, non-grease, to the vineyards, and that was really helpful. It was much cheaper for the growers over there. And do nutrients in the ground, would that make any difference in the quality when something else is lacking? Can they make up for heat, sun, water? Can nutrients
Okay,
make
good.
the growing better?
Yeah, so, okay. So yes, grapes need a certain amount of nutrients in the soil. I mean, if you don't have it, they won't grow properly. But actually controlling that is one of the tricks growers use to manipulate flavor. So you actually don't want too much. If you have too much nitrogen in the soil, the flavors, go south. So the best vineyards in the world actually grow on poor soil. And while grapes don't really think, we think that they do. And you can think of grapes as grapes that have to struggle. And this is when it's described. Grapes that struggle to ripen, okay, make the best flavor. And you can, so under, I would say limiting conditions, again, limiting nutrients, limiting water, you get the best flavor. And in fact, when people plant vineyards in Napa Valley, you have to plant on a rootstock. I don't know if you know what a rootstock is, but many of the trees you might plant in your yard are grown on a rootstock, so that you actually use what's called a devigorating rootstock. So you choose a rootstock which limits the growth of the vine, and that gives you better flavor. Also means that the vine's going to really struggle if you have a problem. Okay, microphone over there.
Hi, I think I saw on one of the slides that Zinfandel was one of the more heat tolerant
Yes,
grapes.
yes.
So regarding, I know there's a lot of Zin in Amador and El Dorado counties.
Mhm.
Are they still in a safe zone for a while or?
Yes, they're in a safe zone for a while. Dry Creek, which is in Sonoma, is another Zin hotspot. I'm more worried about that getting warmer quicker. Part of this is just predicting what's going to happen.
Yeah.
And one of the tricks you can do is go to higher elevation to get cooler weather. But I don't know, then one of the questions is, okay, so let's say Placerville is perfect for Zinfandel right now. As things warm up, are these locations at a higher elevation, are they going to see a higher trajectory, or are the valley going to see so what's the temperature differential going to be in 10 years? And that part is, I think, very hard to sort out. So is it safer to stay, higher elevation, or just you have to move? Yeah.
Tom, do we have time for one more?
Your last point relates to my question. Temperatures are rising in California. They're not rising at the same rate around California. Are they rising among the various wine regions at the same rate and within various wine regions?
Yeah, I'm not a climate scientist, and I've heard different predictions. I've heard a prediction a couple of years ago that, basically the Central Valley, they will not be able to grow anything in 20 years or whatever. And then I've also heard, so part of the trick is understanding all this climate dynamics. So Napa and the coastal areas of California are cooler because of a breeze from the ocean, right? So if you go down to the Golden Gate in the afternoon in the summer, it's friggin' cold and it's foggy, right? And this fog is blowing in off the water, and that goes right up into Carneros and up into Napa Valley. So if you're the closer you are to the bay, the cooler it is, right? And the closer you are to the ocean, the cooler it is. So you really can't grow grapes right by the Pacific Ocean because it's too cold. You have to be inland at least a little ways. So the question is, let's just call that the air conditioning system. Is that air conditioning system going to keep working, as the climate, as it gets warmer, or is it going to stop working? And no one really understands it well enough to be able to predict that. So that's like the big question, because all of our valuable grapes are in the coastal areas. If that air conditioner shuts down, then, well, we got to move north. But if it keeps working, then we may not be that impacted by rising temperatures. So it's a, okay. Invite Greg Jones. He's the climate guy from Oregon. He does all the viticulture climate work. So.
All right, Andy, thanks very much for that presentation. We got a couple of finalizing slides here. We are giving you an honorary membership to the Renaissance Society, which we hope you enjoy. There's lots of things to learn about.
Hey.
And we also are giving a monetary donation to the Seth Nelson Student Emergency Grant Fund, which they really need it these days. So